Dr. Rita Caldwell, Distinguished University Professor both at the University of Maryland and College Park and at Johns Hopkins University Bloomberg School of Public Health. She is also the 2018 Lee Kuan Yew Water Prize laureate. Dr. Shane Snyder, Executive Director of the Nanyang Environment in NTU, Nanyang Environment and Water Research Institute. Dr. Onchu Nam, very good friend of IWP, Professor at the School of Public Health, National University of Singapore, and Director of NUS Environmental Research Institute. Dr. Soon-Thiam, Professor and Deputy Director of Advanced Engineering Platform, Monash University, Malaysia Campus. And Dr. Venkateshu Dameri, Professor and Director, Water Resources Center, Texas Tech University. Thank you to all of you for being here. The title of our session is Connecting Advances in Science and Technology with Public Policy. We know, we hear, we live that technological innovations are increasingly disrupting institutions, organizations, markets all over the world. An example, simple example is internet, which is now integrated into every aspect of our daily lives. Tomorrow, emerging technologies will drastically alter the landscape in which we live. From the public policy perspective, however, it is very difficult to policymakers, regulators, public, the media, to predict the rate, scale, and impact of advances in science and technology in a specific socioeconomic environments. In the field of environment and natural resources, including water, there are numerous examples of how policies have affected positively and negatively environmental quality and natural resources management. There are also numerous examples of advances in science and technology that have the potential to contribute to the success of policies that can solve pressing challenges the world is facing at present. Examples include, for example, cleaner energy technology, or, very important for Singapore, water resources production. So the potential for the use of science and technology for policy formulation is great. But there are also many limitations, and we have to be wise enough to recognize them. They include issues that are inherently scientific: data availability, data quality, technology adoption. But this also includes the need to understand, both by scientists and policymakers, of the socioeconomic context where these scientific advances and technological innovations will be used, or we hope they will be used, the extent of the impacts, and how they can be used more effectively in the long term. So the use of science and technology is influenced by political and economic forces, we know, including the policy beliefs of elected officials, the health of the economy, anticipated costs and benefits of laws and regulations, federal, state, municipality relations, public and media opinion, efforts by corporations, by non-governmental groups and scientists to influence public policy. So this nexus, these advances in science and technology with public policy, depend on many factors. So we are going to discuss several topics, and I will address my first question, or I will ask Dr. Caldwell to comment on the first aspect, which is how government support, how can government support be for the vital advances in science and technology in the area of water?
Thank you. I'm pleased to have the opportunity to speak about science, technology, and policy, particularly, and I'll use as an example, genomics. Genomics is now in a major revolution around the world. The advances are incredible. The capability of application to water treatment, I think, is just beginning, and really government support is needed, first to encourage, second to provide the support to ensure that it becomes implemented, and thirdly to assure standards, and finally to deal with problems of ethics that come up whenever genetics and genomics are discussed. And so to be brief, For example, in the genomics revolution, it's now possible to use DNA extracted from water systems, samples, and to be able to analyze completely, accurately, everything that's in there, quantitatively as well as very specific identification. This now makes it possible to determine without equivocation that the water at the end of a treatment trail is safe. And I think this allows us then to be able to ensure, in a way that we never could have been before, the safety of the water that we use for drinking and for public health applications. Now, this means that it needs to be encouraged in the sense that the tendency is for bureaucracy, industry, to be very slow in adopting any new kinds of technology, mainly because of the investments that have been made in what they're currently doing and wanting to get the return on the investment before they introduce any new technology. But the government policies can be such that it enhances the incorporation of the technology at the same time that perhaps the current technology continues to be used to a point that the new technology can take over. Another aspect of the government policy that's critical is providing the standardization of the operation so that it is accurate, whether it's being done in one part of the country and in another part of the country, so that, for example, in the US, the National Institutes of Standards and Technology now has incorporated a genomics component, so they now can provide standards for DNA extraction as well as for reference standards. And then finally, there always is the question of ethics in the sense of when one develops the capacity to know when there's a health problem, that it is done, it is analyzed, and it is made public in a way that allows the information to be provided without necessarily endangering the economic strength or the public health of a given individual, but that the public then can be protected. So it's a multifaceted approach, and I do think Mr. Tan's talk was superb. He spoke of system and integration, and certainly in the case of application of genomics, it involves information technology because the analyses that are done are really big data type of analyses, and genomics, biology, and public health. So I think the role of government is really very critical to stimulate, to incorporate the new technologies, to make it happen as rapidly as possible, but at the same time as safe as possible. And I think that's kind of a heavy answer to the question.
Thank you very much. Chunam, precisely on this topic of public health application, can you also comment to us how you see this government support, not necessarily here, but in the different places where you have worked, government support or private sector support for technological development, but that affects public health?
Right, I think to me, if I'm not wrong, I happen to be the only Singaporeans on this panel. I just talk about it from the Singaporean perspective. Yes, and I happen to be involved and working with Mr. Tan for quite a number of years on this public health issues. And I think Mr. Tan, I came in late. I do not know whether he told you a story. The new water, just started from 1998. In fact, in 1975, there was a group of very brave engineers who tried to recycle water from toilet to tap, and it was led to failure. That was in 1975. We know water is some sort of basic asset. And what are the failure is because the technology did not come on the right time. And because public health at that time, our scenario is very much similar to many of the developing countries. So it took quite some time for the right technology coming on the right time. So being a person who work on public health, the infectious disease is still 75, 80 is still not too bad, but now we're evolved to today. We can have a whole spectrum looking into not just common pathogens, common viruses. We are able to handle many of the compounds, which others have not looking into. For example, some of the emerging compounds. I just came from the other sessions. We're talking about nanomaterial, nanoplastics, which are very topical. So definitely that sort of government vision support, as well as industrial partners that come in, they do see technology will be needed in future to handle some of this problem. And here we see when it comes to water, the fundamental, if we are going to use it for drinking purpose, public health consideration is definitely of utmost importance. So if you are targeting for the mankind public health issues, I think the support from the government is utmost important, and industries could play some sort of supporting role as well.
Thank you very much. Shane, let me ask you about, with all your vast experience on this, is there such thing as a portfolio of policy actions and instruments that we can direct towards technology implementation, technological development? At what point are we in this moment, for example, in your area, on water quality?
There's millions and millions of chemicals in commerce, and every day 15,000 new chemicals are registered in chemical abstracts. We're in a situation that we can never win. We can never catch up to the pace at which we're developing synthetic chemistry. And so at the same time, we're seeing a lot of new technology and analytical that's allowing us to detect things at lower and lower levels. So one of the ways that people have coped with this from a policy standpoint, at least I'll speak to the California model of water reuse, we put multiple barriers in place and we add more and more energy to try to remove everything to non-detectable levels. But when the analytical methods change, when that technology changes, the things that were non-detectable are today's emerging contaminant. And so we're seeing a shift in paradigm that ironically crosses back over into genomics of looking at using like human cell culture or in vitro bioassays, now organoids that are grown from stem cells and metabolomics. So we're seeing this transition, and at least in the United States at a federal level, things are so slow to move. But at a state level, we're seeing the state of California now drafting regulations that would implement this new technology. And I think the reason I'm bringing that example up is I think this is a leap forward for public health, where we could use a human cell system to gauge the water's quality versus meeting 200 standards that are somewhat arbitrary and often use animal models that are also flawed. The animal testing is also not perfect for mimicking the human body. So that's just one example that's near and dear to my heart.
Thank you. Now let me go with Venki and then with Soon-Thiam. Let's move to another part of the world. You work in Texas, but you also work extensively in India. Right? Technology is different. Regulation certainly will be different. So if we move this policy technology dialogue or situation to India, which is a subcontinent and is going to vibe from one place to another, and after Venki, Soon-Thiam in China, how do we see it?
It's made a lot of progress from where it was in terms of using technologies. 2040, we're going to have telephone in every village, and in the mid-90s, the government just dropped it and said, we don't need this because everybody has a cell phone, so same thing you see with some of these technologies, arsenic was a big problem, and continues to be a problem in many parts of India, particularly, in the Indo-Bangladesh, Gangetic region. I remember seeing a talk in late 90s where people had drawn up this very extensive water treatment technologies to clean up arsenic, and the problem was there was no centralized water treatment in many places, so it was not the right technology, and the right technology was going to each well and testing it and putting a cross or putting a checkbox saying, you can use this water versus not use this water. So thinking in terms of technology, I think, should be ground up. It should be adaptable to what's in that country as opposed to trying to borrow technologies and bring in. There is certainly a certain merit to borrowing certain technologies, like Dr. Thiam was mentioning in his talk, but at the same time, trying to make sure that the technology is correct to that particular situation becomes very important. And I think that's where the government has a very large role to play in terms of what kind of research gets funded and what kind of things happen. So in a lot of academic institutions in India, there's a big push to publish in top journals, U.S. journals, but the problems that they're dealing with may not be the same problems that Americans are dealing. So they end up doing a lot of research, which is very beneficial to Americans or to Western world, but not very beneficial to India. So changing that policy and trying to create incentives where you say, your research has to have a certain merit. Like in the U.S., NSF went to this broader impacts, there's a big push in saying you do basic research, but you got to have a broader impact statement, or you have to make an attempt to link it back to the society. Trying to bring those kinds of things, I think, are very important as we look at technology in developing nations, with India as an example.
So as before Chunam mentioned, and now you mentioned again, at some point when the technology is not appropriate.
Right.
But what about the policies, Soon-Thiam?
You asked me about policies, and you mentioned about China. Now, I do not know whether I'm the appropriate person to talk about China, but I do have some, 10, 15 years of experience working with China. More recently on the Sponge City project, which I think a lot of people know that it's a very huge initiative done by the Chinese government. So let me use that as an example, because I was very fortunate to be part of the initial initiative started in 2015. So I think that is a good example of policies coming in front of the technology. What the idea was then was to be able to utilize stormwater and minimize the diffuse pollution problem that actually occurred over there in China. So it has been decided that, then the idea is to adopt the LID, or Sustainable Urban Drainage ideas from the West, and implement it in China. The policy is there. However, during the implementation stage, we find that a lot of the technologies were actually not developed in China, in that particular country. So now all these technologies have to be borrowed into that country for adoption. Just now, Mr. Tan also mentioned that we have to view policy as a fairly long-term idea. So we have to do very long-term strategic planning in terms of 20 years, he was mentioning about 50 or 100 years. I do not know whether there is any government that enables us to do that type of long-term planning anymore. But for that Sponge City implementation, we are talking about a 3 to 5 year planning, 3 to 5 year project to see it from implementation to fruition. That is an example where I do not see that there is sufficient technology development. There's not sufficient support in terms of government funding, in terms of to the technology development in order to support this initiative. So I think that's, I'm just bringing up probably a negative example to show the linkage between policy and technology.
Now, Chunam, you were working together with WHO on the guidance for water reuse that was launched last year in Spotlight.
Yes.
And it is a guidance. It's like Shane says, it's
right.
Not mandatory, it's a guidance. And even then, it is expected to be followed. What is the objective of this guidance?
Okay, WHO published water reuse guideline last year, and this year at the Singapore International Water Week, it happens to be one of the hot topics being discussed. So here it depends on the technology. I think when it comes to water reuse, it's not just purely technology. I think it's very important to see the acceptance, to see the technology, whether it can be adopted by the local users and the regulatory aspects as well. So sometimes we are rather concerned. You have this advanced technology, but the technology has got to look into it in a very systematic manner. If you just believe the technology will solve the problem, then you'll be totally wrong. Because here, when we were working on the guidelines, there will be some sort of a very detailed checklist. It doesn't mean that when you have got this new technology, you are safe to get very good quality water. Because the external environment keeps on changing, your source of water could vary, and also technology, the aging of the technology comes in as well. So the sort of, besides regulatory, the operators need to pay a lot of attention on what's going on, right? And we all know when it comes to water reuse, it's based on the membrane technology, RO system, and this all have got certain lifespan. So if you don't follow them up with a very professional sort of manner, you are going to end up with disaster. And this is what is being stressed on the guideline.
Benki, India and Mexico, they could be the largest future markets for water reuse, except we will always remain as the future markets. We will never do it. However, these countries have been discharging for decades raw water, and it's being used for irrigation. Now, if we move all this knowledge, all this technology, all this policy, how could that, if ever, be useful? Is the future of India one that would include treatment of wastewater, if not to the potable or non-potable reuse, but at least the treatment of wastewater? Can any of these guidelines or examples from another countries be useful or not yet?
The challenge in India, or like in many developing countries, is the technology diffusion is not uniform. So there's a place where they put a good technology and people move into it and overwhelm that technology. And then, so it's not happening at a uniform pace, which makes it very difficult because you build a system, you design it to a certain capacity, and you overwhelm that capacity very quickly. Instead of the 20-year design life, it's now like 2-year design life, and we can't keep up with it. And that's been a biggest challenge in India, because of the population. Same thing with Mexico. You get technology and people move to that technology rather than moving the technology to people. Right. It's the opposite direction. So that's been a problem. But I think in terms of recycling, there is a lot of recycling that happens in India, in Mexico, and other places, especially with solid waste. Water, unfortunately, there's a lot of recycling, but it's not more formalized and not treated, which it should be. So as I like to say in my class, either you drink somebody else's wastewater or your own wastewater. That's your choice. Those are the two choices you have. So which one do you want? And people say I'd rather pick other people's wastewater than my own, which is an unfortunate part. But I think formalizing that would be very important. And I think a lot of it is trying to understand the risk pathways associated with indirect use of water. That's having that information, or trying to, if the government can help promote that information, then reuse of water or treatment technologies would come into play. So that's, I think, the biggest limiting factor in terms of people trying to use water. And then also in terms of how water gets moved, there are not good institutions in terms of if there is a big push towards an urban demand, water gets moved out of rural areas much more easily than it does in many other developed nations. So that again plays a role, because then you're scrambling for water for agriculture or some of the lower value uses of water, and that people will take whatever they can get, and that's problematic. So having good institutions to manage water and would certainly help in that process, and also the education of understanding the ramifications of indirect risk or indirect pathways would be very helpful. and moving in that direction.
Thank you. Dr. Caldwell, you have been working on cholera for many years. How has policy changed? Yes, let's put the technology aside. How has policy changed?
Well, that's a very interesting question because, in fact, the focus has been very heavily on vaccination. And I feel very, very strongly that, I'm sure my colleagues would agree, that a fundamental premise is safe water. The fundamental premise is providing water that does not carry the pathogenic microorganisms. In the case of cholera, the bacterium is part of the natural environment, so it's something that has to be removed. It's something that has to be, along with the other pathogens that are present, that have to be eliminated. And so I think one of the concerns is that the technology to take these steps is not easily introduced into systems. The systems have an inertia. Part of it is just the plain cost of building whatever the devices are that are used to treat water in order for it to be safe for people to drink. But it's also, there's a kind of lag that occurs just from delay, not understanding and not really wanting to take the risk of introducing a new technology. And that, I think, is very unfortunate because it really puts people's lives at risk in a way that they're not really accountable for the fact that they are putting people's lives at risk. So there has to be a mechanism, a policy that allows the new technologies to be incorporated as soon as they have been deemed, tested, and worked to be safe and effective. Then there should be policy stricta that allow these technologies to be incorporated and applied. I really think fundamentally that the development of any country, any city, really depends on the ability to provide safe water and sanitation. And I think if this could somehow be kind of global golden rule, that it would be best, I think, for all countries to be able to understand that first and primary is providing safe water, distributing it, and having sanitation mechanisms in place. So the cholera story, I think, is a good model. It shows how you can make a big difference in small ways, like simple filtration in villages where they don't have access to central treatment, all the way to being able to understand the genomics of the bacterium and how flexible it is in responding to the environment, and to be able to track it sufficiently to control epidemics. So it's like the alpha to the omega.
Yes. Now, Soon-Thiam, without it being necessarily related to public health, but with your experience and your work in Malaysia, again, examples of technology, of policies that either there is a mismatch or not, that they may be working.
Back in 2002, the Malaysian government started to look at, how they can encourage more investment into water supply treatment technology, because during that time the water treatment was the investment in water treatment was basically done by the state government. At that time, they were looking at policy instruments, they were looking at financial instruments on how you can encourage subsequent investment or more investment into water distribution and water treatment, simply because of the data technology that they have, the data water distribution network that they have. So they have actually devised quite a number of policy instruments. What we now see is that some of these policy instruments have not been, even after so many years, since 2002 until now, after so many years, has not been fully adopted by the different states. Because in Malaysia, you have the state government and you have the federal governments. The federal governments would essentially provide the resources to do that, where the state governments decide whether they want to adopt that particular instrument or not. So you see a lot of reluctancy in the state government in adopting it. Basically because of many reasons, the state feels that they have a difficulty trying to explain why they would want to adopt such policies to the general public. The other one is they feel that they can actually do it much better than the federal, so why should they adopt it? So there's still a lot of debate, and it would make a fascinating studies to actually try and understand what is actually going on there.
Yeah, and very much what Shane also said, the states may go ahead of the federal government, but then this brings us back to Singapore, Chunam. Chunam, perhaps decisions may be easier in Singapore because it's one level government, but also because it is an efficient government. And all of us, and many people in the sessions look at Singapore like, this is where we would like to be. We would like to develop so quickly, and we would like to stay there. And you have seen the changes of Singapore from 1965, time of the independence. Again, coming back to the topic of public policy, what have been those policies, technology or otherwise, that have helped the country to progress?
Okay, it's a tough question, and it's a very good question, not easy to provide the answer. And I think when it comes to water, now with a new government in Malaysia, issue is being bring up again. So here, we need to have a fairly consistent sort of a policy. And since 1965, our founding Prime Minister, Mr. Lee Kuan Yew, takes water as a very important asset. So that sets the bottom line, because water is for survival. So fortunately, for those who are working on water, happens to have an opportunity to embark on the research and to come out with a technology that could match our policy. So the policy has been consistent, and here it's fortunate in the sense that when we find there's this stress, there's this pressure from outside to go for some assets which are fundamental, very important for our population. So in this case, a lot of technologies have been moving in. So a lot of investment have been putting in to look into water technology. So for those of us who happens to involve in it, we are fortunate to embark on quite a number of projects. If you can ask me, policy does come in, and timing is also very important. I did mention about 1975, 76. We were very brave, but we never gave up. But it's timing, technology suddenly come in, while membrane technology, the price happens to be, I think, acceptable based on Mr. Tan, that sort of GDP. At that case, we feel it's worthwhile to experimenting on that. So here, I think one of the very important part is to dare to take risks. But frankly, if you look at that sort of technology growth, at this stage, Singapore, when we are coming to the top, and how to maintain the top is always extremely difficult. There's only possibility of coming number 2, not necessarily to maintain number 1 all the time. So as a person who happens to be involved with water technology or public health sciences, what we feel the government happens to be encouraging on research, but to the youngster generations, we happen to be short of the guard to try on new technology. They are not there to take risks. And also our policy do not really support those failures, and they feel the Asian sort of a feeling that once you fail, it means you have no second chance. So in United States, in Europe, especially in California, the sort of dare to take risks is what our younger generation should learn, and trying to excel for the next stage in terms of matching the technology as well as the policy.
May I request to all of you to think on a closing statement while I ask a last question to Shane Snyder. I remember when Shane came first time to give a seminar in IWP, very comprehensive seminar. That was very much on the topic I like, water reuse. And that was the policy, the technology, and the problems in the policy. And I think that was very enlightening because somehow from the academia, we tend to think, oh, politicians are dumb. They really, I'm not listening to the academia, we have the answers. However, many times in the academia, we don't have the full panorama. Many times we don't know. Or we provide what we think are responses that wouldn't be useful in practice. So could you please comment on that, on whatever context you want to put it, either US or elsewhere?
In their case, in academia, I think many of us believe that it can be done without having reverse osmosis, without having to have a very expensive barrier, which also means approximately 20% of the water supply is lost in the creation of a brine. And it also it also means that only utilities along the coast can employ the technology. Because if you're inland, like in Sacramento, you would have nowhere to place the brine. So recently, we've just approved surface water augmentation in California, which previously was not approved. You had to inject into the ground or infiltrate. And I think all of academics in the US were very disappointed to see that California mandated the use of reverse osmosis before they blend in an open surface reservoir, which is birds are landing there, there's other urban runoff entering. And it just seemed, a bit illogical, but I think the driver for it was to err on the side of caution and maybe be consistent, but yet it really wasn't a scientific-based decision. And just one more on that. The other one that they did was how long the water would have to stay subsurface once injected. There was a theory that there was a 1 log removal per month that the water was underground for disinfection, but when we asked the regulators to see the scientific data, there was none. So sometimes we see that disconnect between the science and the policy. The reason for it, I don't know. I'm not a policymaker. So.
But even then, for example, in the United States, Shane, Dr. Caldwell, Venki, there is the politicians, the regulators, they know there is science. They know there is technology, and many times they use it, and they know at the end they will be responsible, right? But they know it exists. It's not like in Mexico we don't have. Or it's at a different level of the person who is a politician is not the best person. So he won't know. But in US there is. Am I correct on that?
Not necessarily, I think. I wish, first of all, that they did know the technology, and secondly, that they would apply it. In fact, my strong feeling is that we are now at the point where we can determine with exquisite precision the presence or absence of human pathogens in drinking water supply. And what should be done is both policy and developing the technology implementation so that this is done, because it really is a fundamental public health need to be able to be assured that you're not transmitting disease by a water system in the given locale, whether it's a city, the state, or the country, or globally. And so I think, we're able to do it. We really should have the investment to get it done and implemented, and an appropriate policy so that it's standardized and regulated, but also implemented in a way that is appropriate to the environment.
Thank you. Venki, if you could all give us your closing statements, please start it with Venki.
Okay, I think the key issue to fostering the science policy dialogue is transparency, making data available or making it open so that there's a public debate or people can start doing it. And on a positive note, I was in India recently, and trying to get groundwater data in India, like many other parts of the world, is a nightmare. But I just saw that the government of India has put in a portal, and They're putting out data. It's not perfect. I mean, I saw some 800 milligrams per liter arsenic, which is non-existent. You can't have that in it. But at the same time, there was a lot, and the data was not easy to download. You had to go through multiple hoops, and really, but still, it's a step in a very positive direction for me. Is being able to have that data out there so that people who have not collected the data or who don't have a vested interest can still go look at that data and make sense of it and start saying hey, have you looked at it? So that has been that I think is very important, and especially these days with technology, information technology being so readily available. I think it's almost a crime if governments don't allow that data to be made open and made public and foster good science and good policy at the same time.
Thank you very much. Soon-Thiam, please.
Yes, I think we are in a session of connecting advances in science and technology to public policy. So I'm a science and technology person. I always think that whether policy should come before advancement in science and technology, or whether the advancement in science and technology can come actually before policy making. I think when we take everything into consideration, and especially look and learning from what Mr. Tan has mentioned in his talk earlier, I think two of them have to come hand in hand. There are some policies that may preempt science and technology development. There are also policies that may encourage the development. There are policies that may help us adapt or adopt science and technologies and advancement. But I think coming back to water, or policies that are in science and technology that is related to water, we have to remember, or I think my message is we have to remember that water is not a means to an end. Okay? When we study water, we have to actually understand the broader issue that is related to water. Mr. Tan mentioned things like solid waste management as a good example. There are also other things like land use management, housing, many other policies that is actually related to that. And I think we have to bear that in mind when we actually consider water. Water policy.
So it's not only water.
Yep.
Thank you. Chunam, please.
Yeah, I fully agreed. I think we should not just look at water as water. It's not just water quality, although I'm having interest in water quality. We have to look into in a very system sort of requirement, residence requirements, housing, planning, distribution, transport, all this come to meeting the requirement of the residents. I think that is very fundamental.
Thank you very much.
We spend a lot of money, frankly. If you look at petroleum, the refining cost comparing to good quality water, the ratio is actually very high. So I think we should treasure every drop that we drink.
Thank you. Shane, please.
Hey, just two quick statements, in closing. But the first one is thinking about the policies that we're implementing with water reuse, because that's near and dear to my heart. Junab and I are both on WHO's panel. But to be thinking that those kind of guidelines probably should be applied to all sources of water, especially in countries where you do have sewer systems that are discharging into rivers at maybe 90% effluent, but yet we're applying a different standard if we're intentionally recycling, and a different standard if we're just pulling water out of a river with numerous sewage discharges upstream. So that's one area I think we have to get our minds around the policy. And then second, quickly, is again back to the chemical regulatory paradigm. In my opinion, that paradigm is completely broken, where we're relying on in vivo animal testing, which is too slow, too expensive, and many would say unethical, and move towards more of an in vitro bioassay type of screening, at least for monitoring and at least for prioritizing. There's too many chemicals, and we are never exposed to one chemical at a time. We are always exposed to mixtures. So that whole regulatory paradigm, in my opinion, is broken. So.
Right. Thank you. Finally, Dr. Caldwell, please.
Well, first of all, I think that it would be very helpful to have policies that allow the plant operators to be able to implement new technologies. Every day they have to deliver to the public, and they're under the gun. And they really need the support to be able to carry out their jobs effectively. But at the same time, it ought to be policy that allows them to implement the new technologies in a way that the public is educated as to why they're doing that. I come back to Mr. Tan's lecture. He included public education as a major component. And I think if the public understood the benefits of the new technologies and the failures of the old technologies, that would make it easier for the guys the people who are, under the gun to deliver, to be able to work together to get these new technologies applied. And right now, clearly, we're in a position to be able to determine the presence precisely of pathogens. And again, it's a mix of pathogens that make people sick, not just the single ones. And understanding that, I think, is important. So policies that help people get their job done.
Thank you. Thank you very much to all of you. So the topic of technology and public policy is institutions, transparency, regulations, public education. Is much more complex and rich than that. Thank you very much to all of you. Shall we thank them?